Hi! In this short lecture we will study how we can measure seismic waves, which we can later use to find out what is going on inside our planet. Historically speaking, measurement techniques for the solid Earth have started with observations on the Earth's surface, as there is no easy way to directly look inside our planet. Deep drilling projects have been carried out, but they reached only a depth of about 12 km, which means that they penetrated only about a third of the continental crust. So how can one get more information about what is going on inside our planet? Well, already in the ancient world, people noticed that the vibrations after an earthquake are containing different components. For example, in China, a large, elaborate bronze vessel was constructed with dragon figures holding bronze balls. When an earthquake occurred, a ball would drop into the dish below, indicating the direction of the earthquake. What started with such beautiful instruments developed into more complex technologies. Scientists found out that the vibrations can be attributed to different ways of wave propagation. But how do we measure these vibrations when everything is shaking? The instruments that provide us such measurements are called seismometers or seismographs. They make use of a mass that tends to be in rest because of its inertia, even the ground starts shaking. A simple seismometer would be, for example, a mass hanging on a spring. In that way, the mass can stay at rest while the frame will follow any movement of the Earth's surface. Any relative motion between the mass and the Earth is then detected. Such movement can then be, for example, recorded on a rotating drum attached to the frame and a pen attached to the mass. Similar systems can be designed also to measure horizontal ground vibrations, therefore enabling us to measure three-dimensional components of a seismic event. This is how a classical seismograph looks like. But what would such an instrument actually record? In general, seismic waves are elastic waves that propagate through the Earth's interior, which can be either solid or liquid. These waves belong to two families, body waves and surface waves. Body waves travel outwards from the source and they can travel through the Earth's interior. In general, two types of body waves can be identified. Pressure waves, or primary waves, often abbreviated as P waves, are waves that compress and expand the ground in the direction that the wave is traveling. P waves are the fastest wave in solids, and they are therefore the first waves to appear on a seismogram. Shear or secondary waves, often abbreviated as S waves, are the waves that relate to motions perpendicular to the direction of propagation. On the other hand, surface waves, as the name suggests, are not diving into the interior, but are guided along the Earth's surface. In general, surface waves travel at slower speed, which means that they are reaching a seismometer after body waves have passed that instrument. Like body waves, two main types of surface waves exist. Love waves are horizontal shifting of the Earth during an earthquake, whereas relay waves show motions that are similar to those of waves on the surface of the water, which means that this propagation type kind of rolls away from the source. Knowledge about seismic waves is an excellent starting point for finding out more information about the interior of planet Earth. But let's stop here for now. Thanks for watching. See you!